Good morning, students. Welcome to video lecture on Artificial Intelligence and Machine Learning with Python. Subject code U18EC502A. Topic Python code for naive-Bayes classifier. Naive-Bayes classifier. Naive-Bayes classifier is a supervised learning algorithm which is based on Bayes theorem and used for solving classification problems. It is mainly used in text classification that includes high-dimensional training dataset. Naive-Bayes classifier is one of the simplest and most effective classification algorithms which helps in building the fast machine learning models that can make quick predictions. It is a probabilistic classifier, which means it predicts on the basis of the probability of an object. Some popular examples of naive-Bayes algorithm are spam filtering, text classification, sentimental analysis, and recommendation systems. Bayes theorem. Bayes theorem is based on conditional probability. Here, H is hypothesis. Hypothesis means estimated output. E stands for evidence. The probability of H. It is the probability of H. It is the probability of hypothesis before observing the evidence. Probability of E. It is the marginal probability with new evidence under all possible hypotheses. The next is probability of E by H. It is the probability of evidence given that our hypothesis is true. I repeat, it is the probability of evidence given the hypothesis is true. And P of H by E. It is a posterior probability. It is the probability of hypothesis given for the observed evidence. Means, once again I repeat, probability of hypothesis for a given evidence. And the formula is written based on Bayes theorem. Types of naive-Bayes models. Naive-Bayes models classified into three types. The first one is Gaussian model. The second is multi-nominal, and the third is Bernoulli. To classify the data using Gaussian model, you can incorporate the Python syntax to the earlier classification algorithms uh, like support vector machine logistic algorithm by replacing the sufficient codes will classify the data using naive-Bayes algorithm, and the uploading libraries and the relevant commands are: you need to upload the library that is associated with Gaussian model, that is from sklearn.naive underscore base import Gaussian NB. NB means it is a naive-Bayes algorithm, in that it is Gaussian model, and this classifier is available in sklearn.naive underscore base. And the next is defining or assigning model to the variable, and it is clf dot fit of x underscore train y underscore train will train the model. These three lines are to be modified or incorporated in the previous algorithms we discussed. so that you can classify the data using Naive Gaussian classifier. Working of Naive classifier. Working of Naive classifier can be understood with the help of below example. Suppose we have a data set of weather conditions and corresponding target variable is play. So using the data set, we need to decide that whether we would play or not on a particular day according to the weather condition. To solve the problem, we need to follow below steps. Step 1, convert the given data set into frequency tables. Step 2, generate likelihood table or probability table by finding the probability of given features. Uh, Step 3, now we use Bayes theorem to calculate the posterior probability. These three steps are to be noted down to solve the problem theoretically. And a sample problem on Bayes theorem is the data set given for 14 different rows. Here outlook, humidity and wind are features, and play is target. Based on the features, we need to predict the target for a given new data. And here in this problem, we have to predict the play percentage when the outlook is rain, humidity is high, wind is weak. For this problem, we need to determine the play percentage. For that, you need to follow the three steps we discussed in earlier PPT. The first is we need to prepare the frequency table. The next is probability of frequency tables. And the next is the last step is calculating posterior probability based on Bayes theorem. Step number 1, convert the data set into frequency table. Refer to one of the features outlook, another feature is humidity, another feature is wind. Outlook, humidity and wind are feature variables, and based on the labels of feature variables, we need to prepare frequency table. Refer to the frequency table. And the next step is to prepare probability for the frequency tables. Step 2, generate the probability table by finding the probabilities of given features. Likelihood means it is probability. Uh, Refer to the probability of features or input variables. Features are nothing but input variables, and target is nothing but output variable. Step 3 is to calculate posterior probability for the given problem. The likelihood of yes on that day is outlook rain by yes, humidity high by yes, wind weak by yes multiplied by yes. It is based on conditional probability Bayes theorem, and substitute the probabilities given in step 2. We'll get the likelihood of yes on that day is 0.0476, and in the same way calculate the probability of no, rain by no, humidity high by no, wind weak by no multiplied by no. The no probability is 0.0457. And so as we can see from the above calculation that uh, you can observe the probability of yes is greater than probability of no. So player can play the game. Here we need to calculate the posterior probability. Uh, the posterior probability can be calculated as probability of play yes percentage is equal to the probability of yes divided by probability of yes plus probability of no. And probability of no percentage, uh, that is posterior probability of no is probability of no divided by probability of no plus probability of yes, and the calculated values are probability of play. Posterior probability of yes is 51.01 percentage, and the posterior probability of no is 48.99 percentage. The player can play the game with 51 percentage. Python code for naive algorithm. Input library, that is from sklearn import datasets. Some datasets are available in sklearn library. Those datasets can be uh, loaded with the help of this library command, and the data can be loaded with the command load underscore dataset name. It is iris is the user defined name. Iris is equal datasets, which is loaded from the datasets of sklearn with the help of syntax datasets dot load underscore iris. It will load the data. We already discussed the commands are the steps to follow the code to write the code for any classifier algorithm. Step number one is import library, supporting libraries for datasets, for pandas, for training the model, and for classifier. Import all the required libraries. The next step is load data. Step number three, divide data into input output variables. Divide data into input means features, output means target. The next is split the data into training and testing sets. Here you can mention test underscore size, that is equal to the probability percentage is in between 0 and 1. And the next is fifth step, train the model with the fit function. Fit of x underscore train, comma y underscore train. You can utilize this fit function. The last step is predict the output. Prediction step. For any classifier algorithm, you can follow the same steps. Uh, it is step number one. It is step number two. Here, with the help of iris dot target underscore names, you can print the target, and with the help of feature underscore names, you can print the feature names. The feature names are sepal length, sepal width, petal length, and petal width. Features are input, and the target names are setosa, versicolor, and virginica. These are the types of iris species. The next is head command is used to display the top 5 data elements of data set. It is optional. Tail function, it is used to display bottom 5 data elements. It is also optional. The next step is uh, import the library which is used to split the data or yes, split the data into testing and training sets. The library is from sklearn dot model underscore selection import train underscore test underscore split, and it will split the training and testing sets as x underscore train, x underscore test, y underscore train, y underscore test. It is equal train underscore test underscore split of x, y, test underscore size 20%, random underscore state is 0. And this step is to divide the data into features or feature vector and target variables. These are the features and these are targets. Target is assigned to variable y, features are assigned to variable x. And assignment of variable can be done with the help of ilog command also. You can use .ilog command for assigning features to variable x and target to variable y. Now the name-based classifier is defined below. Uh, for that, you need to define the classifier with the help of library from sklearn.naive underscore base import Gaussian naive base. It is a naive base Gaussian model, and the classifier is assigned to a user defined variable CLF. You can rename the variable as per your requirement. And the next is CLF.fit classifier Gaussian naive base dot. Here the Gaussian naive base is assigned to variable CLF. So uh, CLF dot fit x underscore train and y underscore train means we are training the model with Gaussian naive Bayes algorithm with the data of x underscore train and y underscore train, and here the testing size is 20% and the training size is 80%. And the last step is y underscore predict CLF dot predict of x underscore test. Uh, the prediction of output is based on the test variable of feature vectors or feature variables. And if it is a linear regression algorithm, R square value plays important role. But in case of classification algorithms, model accuracy plays important role. And for any classification algorithm, we need to calculate the accuracy of the model. It is based on confusion matrix. Uh, the confusion matrix is the accuracy of the model is true positive, true negative divided by true positive plus true negative, false positive plus false negative. And to determine the accuracy of the model, we need to import the library From sklearn import matrix. The accuracy is defined in matrix, which is available in sklearn library, and the syntax is print accuracy. It is a simple print command to display the value of accuracy. This can be calculated with the help of the syntax matrix dot accuracy underscore score. It is calculated on y underscore test and y underscore predict. For the given data, the accuracy is 96.6%. And here we are going to predict the output uh, for the given feature values: sepal length, sepal width, petal length, and petal width. What is the type of species it is? It is Setosa. And for these values of sepal length, sepal width, petal length, and petal width, uh, the naive-Bayes Gaussian model classifies as it is Virginica, and for the values of given features it is versicolors. Refer to the program. Thank you. We will meet with the next lecture.